All right, Chapter 11 deals with compound interest and present value. And so I'm going to kind of explain the concepts to you both of these concepts to you in this video. But if you look here on my picture, I have simple interest to the right, and that is kind of what you've been working on so far. So simple interest basically is interest on whatever money that you've invested each year. So like, for instance, if you invested $1,100, or excuse me, $1,000 at the end of year one at 10% interest, at the end of year one, you'd have $100 extra. So you've earned $100, right? And at the end of 5 years, again, you've earned $100 every year for 5 years. So after 5 years, your $1,000 is now worth $1,500. The same thing with 10 years. So basically, you're automatically going to earn just $100 a year every year on the initial amount of money that you invested. And that's what we call simple interest. You're only getting interest on the money that you initially invested or borrowed. In compound interest, however, because you're going to get interest not only on the amount that you've deposited or borrowed, but you're also going to get interest on the interest that you've earned. And so if you see the difference here on compound interest, you still had $1,100 at the end of year one, assuming that this is just compounding annually. But at the end of year five, you have, instead of $1,500, you have $1,610. So you have $110 more on the same investment that you had a few years later. And then if you continue on, because you're earning interest on your interest at the end of year 10, you have almost $600 more of interest that you've earned because of its compounding interest. And then if you jump to year 20, you've pretty much doubled your money. Now you're at $6,700 of interest. That's actually $3,700 of interest. You've doubled your money at year 20, between year 10 and year 20. And then if you continue on leaving your money in there, this is the same $1,000, by the way, that you put in the very beginning. At the end of 30 years, you have almost $17,500 compared to what with simple interest? Only $4,000 total money. So you definitely earn a lot more in compound interest. And the longer that it's in, of course, the more interest that you've earned, and the more interest you've earned, the more interest you're going to earn on your interest. So that's why we call it compounding interest. And it's very powerful. It's really the only way to go. And most loans and most investments are pretty much this way when it comes to your payments or your interest earned. So that's what we call compound interest. And another way to look at it is this table down the bottom. And I want to explain this to you because it'll make present value become a little bit more understandable when we talk about present value. But if you notice this chart, you have your known amount. So this would be your initial present value of an amount of money. So let's just say that present value is 10,000, right? So you know what your present amount is. My present value of the money I have right now presently is $10,000. However, through compound interest, I don't know what the future value of that money is going to be, because I don't know what the rate is. I don't know what the percentage rate is going to be, and I don't know how much time that I'm going to be leaving it in there. So I know what it is today. So what I need to find out with compound interest is how much is it going to be worth, or its future value in X amount of time at an X amount interest rate, right? So if I said $10,000 at 10% interest over 10 years, then how much is that amount going to be in the future? So how much interest will I earn is basically the question. And so I know my present value today is 10,000, but I don't know my future value. That's unknown to me. And that's the kind of problem that I'm going to try and solve. Those are compound interest problems. When we get to present value, I'll explain it the opposite way. But right now, I know what I got. I just don't know what I'm going to have. And that's the kind of problems that we're going to solve for with compound interest. So I'm going to start on that. I'm going to go to 11, page 2. So if I can do this a couple of different ways, I can actually manually calculate compound interest. I think to do this really helps kind of put a visual to what we're talking about with compound interest. So we'll look at this first problem. Gail Parker invests $10,000 at 6% interest, compounded semi-annually for 3 years. So if she compounds it semi-annually, how many times would it be compounded a year? Anybody? If it's compounded semi-annually, how many times a year?
Maybe 2 times.
2 times a year. So every 6 months, then she's going to be compounding this interest, right? So if that's the case, I'm going to do this, what we call longhand. I'm going to write it out, 10,000. I'm going to use simple interest to figure out the interest first. So 10,000 at 0.06%. And then since it's a half a year or 6 months, I'm just going to do one half. Same thing as 50, 0.50, right? Or I can do 0.50. That'll probably be easier. So let's just do 0.50. So if I do the math on that, it's going to come out. Actually, you can do 30 divided by 2, well, one half, whatever. It's going to come out to 300. So that means at the end of the first 6 months, I earned $300 of interest. So if I add that to my principal, now at the beginning of the next 6 months, this is my new principal amount. So I'm going to earn interest on that for the same amount of time. And that comes out to $309 of interest at the end of 1 year or the next 6 months, right? So if I take the 309 and I add it to my principal amount, now I have 10,609. Remember, compound interest is earning interest on your interest. So I'm just adding my interest to the principal. And I'm just going to every 6 months, I'm going to do another calculation. And at the end of the third period of 6 months, I now earn $318.27. So that's interest I've earned. That's the beginning of year 2. So I'm going to add that to my principal amount. So now it comes out to $10,927.27. I'm going to do the interest on that. And that gives me another $327.82 of interest. If I add that to my principal amount, that gives me a 11,000. That now makes my amount $11,255.09. If I do interest on that, at the end of beginning of year 3, first 6 months, I earned another $337.65. Anyway, if you keep doing that all the way down, I'm not going to keep doing it, you'll end up with, at the end of year 3, in this case, it's how many years? 3 years. The end of year 3, I would have $1,940.52 worth. That's how much interest I will have earned. I would have gone from $10,000 initial investment to a new balance of $11,940.52. So I went from 10,000 investment and I earned over those 3 years. My total new balance is $11,940. That means I earned $1,940 worth of interest. So if I took the same amount of money and I just did simple interest, I would come out to $1,800 of interest. But because I compounded it, I ended up earning $140.57 or 52 cents more using compound interest. So that's what we call doing compound interest manually. And there is a problem for you to do that on the quiz or on the exam. I just want to let you know that. So you are going to do it, but I think I only have you do it for like 2 years. This one was 3 years and I gave up at the beginning of the third year. So anyway, that's showing you. So what you can see is happening here is whatever interest I'm earning is now being added to my principal, right? And so it's added to my principal, and then I figure out the new amount of interest, and I get a little bit more interest at the end of that period. And so then that is added to the principal, and I get a little bit more. And each time I'm adding, I'm getting a little more interest each time it's compounding because I'm getting interest on my interest. Now, by the way, this is the same way that your mortgage works, except you're earning, you're accumulating interest. It's also the same way credit cards work. So you're accumulating interest based off how often it's compounded. So that's the negative side of it. The positive side is if you're investing, you're doing pretty good. All right, so that's the longhand way of doing interest. But now we're going to be looking at a couple of different ways to solve for compound interest, and that is by using the tables. Now, your book provides these tables, and these are very common tables. You can find them in any you can find them on the website. You can find them in most financial pages, but it's basically a compound interest table where if you can figure out how many times it's going to compound over the life of the loan, at what rate, then you can solve the how much money you'll have, future value at the end. And so what we have is, of course, your principal. That's the initial amount of value that you have, money that you have to borrow, or money that you have to invest. That's also known. So we call it the present value known. Then you have the terms of the loan. So how many months or years is the loan as far as length? Then you have the number of times that the loan is going to compound per year. So if it's going to be if the term is 3 years and it's going to be compounded once a year, then it would only be compounded 3 times. But in light of the problem that we looked at earlier here, we said it was going to be compounded semi-annually, which means twice a year. Well, if it's a 3-year loan and it's compounded twice a year, that means it's going to be compounded 6 times, right? So that's what we call the number of periods that it's going to compound, or the number of times it's going to compound. And then you have the interest rate, and the interest rate is divided by the number of times it's going to be compounded a year. The interest rate's always in terms of a year. So if we say it's a 6% interest and it's compounded 1 time a year, then the 1 time that it's compounded is at 6%. However, because the interest rate is in terms of years, if it's compounded twice a year, but it can only be compounded a total of 6% per year, that means every time that it's compounded, it's only compounded at 3%, right? 3% for the first 6 months and 3% for the second 6 months. Or let me just throw a monkey wrench in there. If it's compounded quarterly and it's 6% for the year, that means each time it compounds, because it compounds 4 times, it has to total up to 6% at the end of a year. So that means every time it compounds, it's only compounded at 1.1 1/2% each time. So that way, at the end of the year, it's been compounded at 6%. And so that means that it would be 1.1% each time, or 1.5% each time it's compounded. So basically what you do here is you divide, or you multiply how many times it's compounded in a year by a year, and then you divide how many times the interest rate is going to be, that interest rate is going to be divided by how many times it's compounded in a year. So again, if it's compounded quarterly, that means it's going to be compounded 4 times in a year, right? 4 times it's compounded per year. So 4 times it's going to be compounded. And then your interest rate is going to be divided by those, because each time it's compounded, it's only a quarter of the total interest rate. So it would be 1.5%. So understanding how to figure out these table factors isn't difficult. You just got to keep in mind and write down specifically how many times per year it's going to be compounded, and what is the interest rate per year that it's going to be compounded. So, and once you do that, once you find those factors, then you can use this table by finding the number of times it's compounded on the left column, and then the interest rate on the top column. And you go and you find the table factor. Once you get the table factor, you simply multiply the table factor by the amount of money that you're investing or that you're borrowing, and it's going to give you your maturity value, your total amount of that loan is going to be worth, or that investment is going to be worth at the end of that term. Finding the future value. So again, principal times the table factor, or you can then you also can find how much interest did you earn. Well, then you would take the future value and minus the principal that you originally invested. So those are the things we're going to be solving over the next 5 or 6 problems here, looking at Chapter 11. But we're going to be using the table, and I'll show you how to use the table here in just a second. So Jenny Chow invested $20,000 at 6% interest, compounded semi-annually for 8 years. Use table 11.1 to find the compound amount of her investment. What is the amount of compound interest Jenny earned? So the first thing we want to figure out then is how many times does it compound, right? So that's what we want to find out. How many times does it compound? Sorry, my spelling is really bad. In 1 year. Okay. So if it's compounded semi-annually, what does that mean? Anybody? How many times a year does it compound?
Twice.
So 2 times a year. How many years is the loan for?
Oh,
8
for
years. So I need to first go 2 times 8. So that means it's going to compound 16 times over the life of that loan, right? So 16 is going to be my table factor. for how many times it compounds. And then my interest rate is 6%, right? So 6% per year. But if it compounds 2 times a year, and my interest rate can only be 6 in a year, I need to divide the 6% by 2, right? So that means every time it compounds, it's 3%. So now I just go to my table, and the table factor, so it's 16 times at 3%. Just remember that. We'll finish the problem on the next page. It's $20,000. So 3% 16 times. So let's go to the next page here. And I think we have our table. All right. So here you can see the table. Stretch it out a little bit if I can. It's not letting me. I think I can blow it up a little bit. I guess not. All right, no worries. So if we look on the left table, this is the number of times it compounds. We said 16 times, right? And then we said what percentage of interest? 3%. So I would just see where those two intersect right here. So that is my table factor. So I'd take my original $20,000 investment and I would multiply it by the table factor, 1.60471. So there's my table factor. It comes out to, if I multiply it, $32,094.70. So this is my future value, or my maturity value, after 8 years, compounded semi-annually at 6%, I will have $32,094.70 at the end of 8 years. So that's my future total value. That includes my initial 20,000. So then how much interest did I earn? Well, simple enough. I just deduct my original investment, and that comes out to $12,094.70. So that's how much compound interest I earned, right? So this is what we mean by solving compound interest problems using the table. Now, there is a pretty complex formula in your book, and you're welcome to give it a try, but I'm just going to tell you right now that most students don't get it right using the formula, but they almost always get it right using the tables. So I highly encourage you just to use the tables. But so we're going to do a few exercises here on the next page. We're going to work through some figuring out this information right here. So if you look there, the first one says $7,000 principal. The time is 4. Gosh, I don't know if I have the time correct. Oh, 4%. This is all shifted, by the way. This should be rate right here, and then this should be time here. Anyway, all right. Let's see. What did I do? What did I got? Oh no, I'm sorry. I had it right. My bad. I'm looking at a different chart. All right. So time is in terms of, these are in terms of years. Sorry. Except for the last one, it's 12 months. And then these are, that's correct. This is rate. This is your rate, 13%, 4%, 8%, 18. All right. So what I want to find out here, my pen's low. What I want to do here first, and we'll do this together, is to figure out how many times that particular loan will be compounded, and then what will the interest rate be for that particular loan. So if I said to you that it's $7,000, I'm sorry, I said it was 4 year long, for this. I'm looking at the wrong chart here. Hold on a second. All right. Hold on a second. This is the wrong page. My bad. I wondered what was going on. This is for something else. Let me open a different one. I think the one I want is this it? Nope. You know what? I don't think I have the page. Maybe I didn't do it. Let's see. Open project. All right, so I don't have the right sheet here, so I'm going to just go ahead and do a blank sheet for now for this next one. So give me just a new whiteboard here. All right, so what we're going to do is I just want to have you guys figure out how often will something be compounded. and what will be the interest rate. So I'm going to give you a couple of terms. So I'm going to say this is a three-year loan, and it's going to be 13%, and it's going to be compounded annually. So what I want to know is how many times will it be compounded, and what will be the interest rate? Okay. So that first one, if it's compounded, if it's a 3-year loan and it's compounded annually, then how many times over the course of that life of the loan will it be compounded? Any guesses?
3 times.
3 times, okay. And the interest rate will be what each time it's compounded?
13%.
13%, yep. Because it's annually, right? Remember, interest rate's always in terms of annually anyway, so no problem there. All right, next one is a 5-year loan at 4%, and this one's going to be compounded quarterly. So how many times will it compound? If it's compounded quarterly, that means 4 times a year for 5 years. How many times will it compound?
20.
20. All right. And if it's compounded 4 times a year, but the annual rate of interest is going to be 4%, then how many times, what will the interest rate be each time it compounds? 1%. You said it. So this is what I would go to the table with right here, these factors, right? So let me give you another couple. This one's 12 years loan, and it is a 8% interest, and it's compounded semi-annually. So how many times would it compound? 12 years, 8%. How many times would it compound?
24.
24 times, correct. And then what would the interest rate be each time it compounds?
4.
4. Yep. So basically all you're doing is you're multiplying this by 2 and you're dividing this by 2. Here you're multiplying this by 4, you're dividing this by 4, right? So that's really all you're doing. You're multiplying it by the number of times per year it's going to compound, and then you're dividing the interest rate by the number of times per year it's going to compound. That's all you're doing. Here's a different one. So 6 years, 6% monthly. So how many times will that compound? If it's compounded monthly, that's 12 times per year. Any guesses? How many times will it compound over the course of its life?
Mhm.
What did you say?
1 second. Would it be 72?
Yep, 72 times. So I'm going to take this, I'm going to multiply it by 12 equals 72. And then I'm going to divide the 6% by 12. What does that come up to?
Uh,
1/2%.
Yeah.
So that means it's going to compound 72 times at 0.5% each time. And I can go to the table and I can look these factors up based off of that. So let me give you one more. This one's for 9 months. It is 4%, and it's quarterly. So how many times will it compound? 9 months quarterly.
36. Wait, you said 9 months. Oh, wait, hold on. Sorry.
That's why I put this one down, because I know it throws everybody off.
I see that part.
So if it's compounds quarterly and it does it only for 9 months, that's less than a year. So it's only going to compound how many times?
3.
3 times. Yep. And then what would the interest rate be? 3 times. Well, it's compounded quarterly, so it's still the same. Still going to be divided by 3. So it comes out to 1%. Actually, it's still divided by 4 because it's quarterly, so it still comes out to 1%. Does that make sense? So just be aware if it says months. At this point, it's usually, when it says months, it's usually going to be quarterly. So you can just count how many months. It'd say like 18 months. Well, that's a year and a half, right? So 18 months is a year and a half. So that's 1, 2, 3, 4, 5, 6, going to compound 6 times. All right. I'm going to end with that. It says, as a savings plan for college, when their son Bob was born, the Wilburs deposited $10,000 in an account paying 8% interest compounded annually. And it's asking you, what will it be worth when he's 18 years old? So that means it's going to go for 18 years, right? So pretty simple. It's going to be compounded 18 times. And it's going to be at 8% because it's done annually, right? So now I'm going to go to my table. And if I look at table 11.1, I can go down to 18. And I can go to 8%. And it comes out to 3, the table factor is 3.99602. That's my table factor. I would simply multiply the 10,000 by that. And my answer comes out to $39,960.20. So they put $10,000 in the bank when the kid was born or whatever, and then at the end of 18 years, when he graduates high school, he has $40,000 towards college based off of the 10,000 they initially invested. So they almost tripled their money at that point. Right? So if I go to the next slide, and I look once again at the table, we said 18 times at 8%. They intercept right here, 399,602. And that gave me my answer. I'm looking at the next problem. I'll just do it right down here in the bottom since I don't have anywhere else to put it. You're the owner of UPS franchise store. You deposited 12,000 in an investment earning 12% interest, compounded monthly. Okay, this is going to have me doing one other step that I didn't introduce to you yet. So compounded monthly for 2.5 years. So they want to know what is the how much money are they going to have at the end of that time? What's that $12,000 going to be worth after 2.5 years at 12 pounded compounded monthly? Okay. So if it's compounded monthly for 2.5 years, so we know that 1 year is 12. So 24, 36, let's see, 24 months plus another 6 comes up to 30 times, it's going to compound. Right? Because it's monthly, so it's going to compound 30 times. 12 for year 1, 12 for year 2, and then 6 for year 3. So that's 30 times. And then my interest rate's 12%. So again, it's going to be monthly. So it's going to be divided by 12, which equals 1%. So I'd go to my table. And so 30 times. So if you look at your table, we have a problem here. It ends at 25, but it's 30 times. So how do I solve that? And it's very simple. What you do at that point is you cut it in half. So you go 15 at 1%. So 1.16097. So 1.16097. And you multiply it 2 times because that makes up the 30. So if you multiply those two together, you get 1.34778513. This is now my new table factor. And if I multiply that by the 12,000 times that, I would get 16,174.20. So that's my new maturity value. And that again, so the 12,000 went to 16,000, means I earned $4,174 worth of interest over that time. So if you have a situation where you have too many times that it needs to be compounded, you can just divide it in half. So in this case, 15, and then you take the table factor for 15 and multiply it by itself, and that gives you a new table factor. And that's how you solve when you have more periods than the table gives you. And you could also use the formula, but the formulas, I don't like the formula. So, all right, I think that's enough on these ones. So let's move on to the next page, see if I can figure out which one that one is. Okay, that's the one that I was looking at earlier. So page 5. So here it is. This is where we're figuring out how many times it's compounded, and then we're figuring out the maturity value, then we're figuring out the compound interest. So remember, your compound interest is very important, because whatever your maturity value is, you want to minus the principal from it, right? So in this case, 11,000 minus 7,000 would give us the 4,413. That's how much interest we've earned. And some students don't get this. If it's asking you for the maturity value, you put that in. If it's asking you for the compound amount, then, or compound interest, then make sure you deduct the original investment or principal from the maturity value, and that'll give you your compound amount. So that's all we're doing here. This one says, it's 6 years, compounded semi-annually, at 4% interest, the second one. And so semi-annually, 6 years, I think it comes out to 24 times. And then the interest rate's also semi-annually divided by 2, so it's 2%. So I'd go to the table, I'd find the table factor for that. I'd multiply the table factor by 11,000. The answer in this case comes out to 13,950.64. And then, of course, I would subtract the 11,000 from that to give me how much interest I've actually earned. And it comes out to $2,950.64. So we're not going to go through all those, but basically what you're doing, I'm trying to show you with these problems is I'm trying to show you that you must, whatever your maturity value is you must minus the original principal to give you your compound interest amount. And that's very important because some students don't do that. They'll just put the full compound amount without subtracting it, or they won't figure out the interest amount, or they'll do the interest amount, not the compound total amount. So I just want to show you that real quick. And then this is the creating a new table factor. It's the same situation. Stan Gray has $3,500 to invest, 8% interest for 7 years, compounded quarterly. So again, 7 times 4 equals, what is that, 28? So it's going to compound 28 times, and 8% divided by 4 is going to be 2%. So if I go to the table, so remember 28 and 2. 28 and 2, let's see, open projects, we'll go back to the table. So we're going to do 28, there's only 25. But we did 2%. So again, we take the 14 then, right? What's 28 divided by 2? 14. So I take this table factor, 0.075788, 0.05788, and multiply those together. And it gives me a new table factor of 0.075788 times 0.075788 equals, gives me a new table factor of 0. Oh, I don't think I did it right. 0.075788. Oh, I used the wrong table. Figured something was wrong here. I'm using table 11.2 for present value. Sorry about that. I need to use table 11.1. I thought something went wrong. So 14, 2%. I thought it looked too small. It's 0.757. It's the same thing, but not the 0.0. 0.75788 times 0.75788 equals, there we go. It equals 0.574382094. And by the way, you should really use the whole thing when you multiply it. Then you're going to multiply that, in this case, by the 3,500. That was the problem we were working on. That's going to give you your compound future value. And then you deduct the difference from the 3,500, and that'll tell you how much compound interest you've made. So, all right. Now we get into what we call the effective interest rate for compound interest problems. So remember how we did it already for the in chapter 10, we did for the promissory notes. So now we're going to be doing it for effective interest rate for compound interest. So it's very similar. Then remember, effective interest rate basically tells you the actual interest rate you're going to get, right? Based off of the terms of the loan. And so in this case, this is the formula you would use for the compound interest one. And basically, it's the total compound interest for 1 year divided by the principal. That's going to tell you your rate. So if Sherry Smith invested $3,000 at Horizon Bank at 6% interest, compounded quarterly. They're asking you, what is the annual percentage yield of this investment, and what will Sherry's investment be worth after the 6 years? So 6 years is what, but we only need to do 1 year, right? So 1 year quarterly means 4 times, and at 6% means 1.5%. That's going to be my table factor to figure out how much interest was going to happen in year 1. So I would go to 4 periods at 1.5%. Gives me a table factor of 1.06136. And if I multiply that by the initial investment of 3,000, it gives 1.06136 times the 3,000 equals. So my total investment is going to be worth $3,184.08. But I need to figure out how much interest I earned in year 1. So I need to subtract that. So 3 minus 3,000 of the original investment came out to 184.08. So that's how much interest I earned divided by the principal, 3,000. That's going to give me my effective interest rate. So divide that, 184.08 divided by 3,000. $184.08 divided by 3. It's out to 0.06136, or the same thing as saying 6.13 or 14%. 6.14%. That's my rate. 6.14. 6.14%. That's my answer. So again, the stated rate was 6%, but because of compound interest, I actually earned 6.14. By the way, this looks like a question that I'm very familiar with because I think it's on both the exam and the quiz. Here's another one, $2,000 investment at 4% compounded annually. So that's going to be 4 times, or no, it's going to be 1 time at 4%. So 1 time at 4%. It's table factor of 1.04000 times 2,000. That's going to give me my interest rate, or my amount of interest I earned in the first year. So times 2,000. So I earned $80 interest. It's actually 2080, but I'm just going to take the $80. I'm going to divide that by the 2,000 because that's the first 1 year's worth of interest divided by the interest or the principal gives me 0.04. So 4%. I didn't make any more because it was only compounded 1 time. So it makes sense. It's exactly 4%. Had it been compounded multiple times, I could take the same problem and compound it 12 times, and it'll actually be a little higher. It'd probably be 1.2 or 1.3%. So that's what we call effective interest rate. And you're going to need to solve a few problems like that. But just keep in mind when it's asking for the effective rate of a compound interest problem, you're going to take 1 year's worth of interest and divide it by the principal. If it's asking for the effective interest rate on a promissory note, you're going to take the bank discount amount divided by the amount that was of the proceeds times the time, and then that's going to give you your effective rate. So just keep in mind there are 2 different formulas for the same kind of problem. It just depends on whether you're solving for a promissory note or you're solving for compound interest. All right, so I think that's it for compound interest. I'm going to make present value a separate video, but it's going to just be a follow-up to this one. So I'm going to keep going. Do you guys have any questions at this point, Eduardo or Jojo?
I'm fine.
You guys are good? Okay. Well, that ends this video. I'm going to start a new one here. So.